Thank you for joining the August 13th, 2019 VOLTA call. Just a reminder to everyone that these meetings are public and recorded, and we do post them to our YouTube channel after the meetings. So please keep that in mind during discussions and any presentations that we may have today. And with that, the first topic we have on our agenda today, we'd had a request last week for a discussion on VOL 1841 and the transaction lifecycle in VOLTA Core. And so the first topic today is to allow some time for that discussion. Let me make sure. Ken, do we have you on the audio bridge yet?
Yes, I'm here.
Great, okay. And then once we're done with that, then we'll move on to a review of new issues that have come in over the past week. And if we have any remaining time, then we'll quickly run over a few Sprint 5 status updates. So the first item, let me go ahead and switch over. I've just brought the JIRA up here. Ken, did you have anything you wanted to bring up on your screen, or just a verbal discussion with the group?
Actually, I would like to bring something on the screen because it's
okay.
kind of related.
Let me give you presentation rights. And we can see the slide.
Oh, you can see the slide? Okay. Okay, so this, I raised this JIRA because in the core, whether it was 1.x or 2.0, and the transaction model is very, very simple in the sense of, if we look at this sequence diagram, can everybody see my screen?
Yes.
Yeah, okay. So this is a high level, but it's kind of a pattern that we follow in the core today. I remove a lot of details here. I just put the highlights. So pretty much we'll get a request into the core. I call it the V core. And the first thing that we do, if we do some processing, and if we had to update the model, we do an update to that model. And then if that request needs to go to an adapter, we send it over to the Kafka. And then out of that, we can have two different kind of responses. We can get an ACK message that comes back. The ACK is really, once we send a message to Kafka, the adapter gets it, sends an ACK back, and then we get the ACK. And once we get an ACK back, we send an OK back to whoever make that call. So that's a success path. And if we don't get an ACK back, it's a timeout, so we send a timeout. So if you look at this model, really success within the core, all it means is we have been able to update the model and we have sent it out to Kafka, and the adapter has says, I got it. That doesn't mean that the transaction has been successful. All it means is we have updated the model and we have sent it to an adapter. That's it. So the gist of the JIRA that I raised is how can we do an end-to-end tracking of a transaction within the core, if possible. So I was looking at different ways of doing that. And the more I look at it, the more I'm thinking of different scenarios, and I'm coming up with more questions than answers. So really, I've put a few slides together of some of the questions that is coming up, and I would like to get the feedback from the community about it. So far, so good? Okay, so the first question that I have is, what is a transaction boundary? Like, what is a successful and a failed transaction? Currently, like in the core, we say it's a success when we get an ACK from an adapter. If we take some example of some typical transactions, let's take a transaction where we get an enable device into the core. So we create those devices, we update their states, the admin states, we send an enable request to their OLT adapter. The adapter will do these things and then will come up with says, oh, I discovered some devices, some ONUs. It will send back to the core, and the core will send multiple enable requests to the ONU adapter. And then there's a lot of sync between the adapters, ONU and OLT adapters. And eventually we'll be creating the logical device in the core. And once we get a lot of unipoints created by ONU adapter, we'll create the logical points in the core. So if we look at it, we'll get one request, which is just enable device, and that have created a lot of sub requests within the core and within the adapters. So when we say enable device has succeeded, what does it mean? Does it mean that all those different actions and sub-actions have all been completed successfully, or just partially? And which part of it the core should really be tracking? So I'll just go through some of the questions and I'll let you guys talk about it. Another one is receive an outflow request. So the core will decompose those flows, and we'll send them the flows to the OLT adapter. We'll send it to the ONU adapters. Those adapters will send it to their respective devices. And some flows may succeed, some may not succeed. So at what point of time, like, do we track end to end for it? And the other one is we get packet in, packet out request. For those requests, do we need to track them? Does the component that originates those requests automatically do retries? So this is like one question that I had. So what is a transaction boundary? Where it starts and where it ends? In your opinion on those?
So Ken, I think, let's say it's the rebooting the OOT or something like that. My gut feeling is when you say enable the OOT adapter, the response should just respond to the OOT adapter, and subsequent ONU adapter, if you have 1,000 ONU devices, and that. What I'm a little bit cautious here is because I enabled OOT, right? So it's the OOT enabled the state is what I would be interested.
Okay.
Right. And then the subsequent ONUs, I know that's because enable the OOT trigger the subsequent activities, but for the overall, it's the OOT enabled response what I'm looking at, right?
Okay, so if there's a failure during the one of those ONUs being enabled, how do we track that? There's some subsequent slides, some other questions that I have coming later, but it's all come like around that. It's like if we want to, if somebody is going to, or some component, we need to look at this end to end somehow.
The way I see it is if that's a brand new OOT versus, and then the brand new OOT, then they already have ONU attached to it, versus a brand new OOT, you don't have anything, right? Or the other one is OOT already have ONU up and running, register, and the OOT got, for some reason, has a state change, right? I think that's the three minimal scenarios, right? Or use cases. If that's a brand new OOT, no ONU is attached to it, I think that's a simple case.
Yeah.
And the brand new
the only thing to consider here as well is the simplified notion of enabled yes or no. There's a whole lot that has to happen between saying, I request you be enabled. The OLT reaches out, the adapter reaches out to the agent and says, get a connection, and then receive indications representing both its own discovery, its port's discovery, and ONU discoveries. And then the ONU goes through its 3 or 4 steps of what enabled means to it. there's a whole lot of states between I told you to enable versus I'm ready to pass traffic. And those incremental steps come from different sources. The OLT telling the core that the ONU is half ready. The OLT telling the core that some of my ports are ready, but I'm not fully ready yet. The ONU telling the core, I've walked all my OMCI stuff and now I'm actually ready to pass traffic. There's a lot of intermediary between versus enabled and done.
That's correct.
Now let's see that life cycle, right? It's hard to know who's responsible for what. Like the core may be responsible for saying, I've got the message, I'm waiting for you to proceed to the next step of what enablement means. But some of it may ultimately come from the hardware itself to say, yep, I am actually an enabled OLT, and here are discovery indications for an OMU. Mm-hmm. So the point here is if we get too prescriptive at a high level of what enabled means, we end up glossing over the very legitimate details of what really needs to happen.
I agree with that.
So it's always hit me that the core kind of says, here's my intended state, right? And then it's up to the other components of the system to essentially work towards that intended state. And so my question is, the core sends an event off to Kafka, to the adapter, say, hey, do this. If that fails, where's the retry, right? Are we always working towards that intended state, like ONOS with its pending flows, if you will? Or is it a one-off, hey, I've sent the request to the adapter, I'm done. If the adapter retries, great. If the adapter doesn't retry, oh well, right? Is there consistency around that?
Currently, it's up to the adapter. Sometimes, like with OpenOMCI, there are a lot of those tasks are on a retry loop. There are some of the OLT hardware indications that will continue to send until told otherwise. And there are some states where if you miss your chance, then it doesn't happen again. And I'd consider those bugs. But right now,
and
in the realm of the adapter to reflect reality properly.
Right, and the question is, if there's no persistence in the adapter, and adapter received the event to start, and then the adapter crashes, is that lost to eternity? That makes sense?
Currently, I believe it is lost.
I mean, right now, the adapters themselves we haven't addressed adapter resiliency yet in the 2.x world. So some of that gets to, how do you deal with that as a first pass? Like right now, if you bounce OLT or ONU adapter, nothing good happens, but nothing's been coded to do anything with it at this point so far.
So it does exactly what we told it to do.
Yeah, exactly. It's just, there's nobody there anymore. You can send messages all you want, but there's nobody there.
Right.
If it comes back and resumes, this gets into reconcile and adapter HA even, what do we want to do in those scenarios? Down. But right now, it is an unimplemented feature.
So I think at a minimal, particularly if there is no standard or resiliency around the adapters today, there needs to be a way to tickle the core, if you will, to resend a request if it needs to, right? So if I've enabled an OLT and some of the ONUs came up, some didn't, and I can't guarantee that the core is going to or the adapter is going to retry, can I kind of get the core to resend the event to tell the adapter to try?
But one question: why some of the ONU will come up, some of the ONU will not? Oh, what I'm saying is
phase of the moon. Who knows?
It's a hyper
or fiber being cut or whatever. But what I'm saying is, when you made that statement, I was wondering if the ONU doesn't come up, what I'm saying is, how do I know it didn't come up? Because I don't have a previous record, right?
You should be able to see in the listing of devices, when you do a list of devices and list of the ports on devices in VOLTHA, you should be able to see that it is enabled, it is connected, reachable, all those good state things, or not. And presumably, if it's not one of those things, then it's not enabled.
Yeah, I mean, the ONUs that happen to not come back would still be in unreachable state. In this particular scenario, yeah, if the OLT adapter says, I don't see this ONU anymore, I'm not sending you an indication to that effect, then that one particular ONU will still be in unreachable state.
Which means the OLT adapter need to be aware what was the previous status of that ONU versus now there's something different, right? If I restart OLT adapter.
I mean, right now, in this case, the OLT will instruct the core based on what it knows. If the OLT adapter comes back and says, oh, I've got indications for a dozen ONUs, but I should have it for 2 dozen, I'm going to tell the core about a dozen ONUs that are now here. The other dozen that haven't been addressed would still be in the state they were before, which is not here anymore. Figuring out why is now an exercise in, well, why did I get these indications versus not? And then it's now, what's going on in the valve? Did the valve get the indication? Is something unplugged? You know, loss of signal errors, blah, 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 blah.
Yeah.
But I mean, that's
I think right now, if I expect 10 ONUs and I only see 1, you know, it's an exercise of going through logs, which is not exciting.
Or events. I mean, this is where the eventing, if it was clear about, you know, oh, there's this one here that's in a bad state, clone can't be reestablished for whatever reason. If there's an event fired for that, then it bubbles up through that channel.
Well, I mean, I'm talking about, you know, you don't even see the ONUs in the device list because something went wrong in discovery. If there's an event that tells me that, great, I have some log capability to trace that.
I guess a difference in tracking a device that was known before versus a device that's never been known before.
Right. I'm talking about a scenario where I expected a device, but I don't see it in my device list. How can I tell what went wrong?
So in the case of ONU,
and debug that.
From the core's point of view, it only expects to say, I'm adding an OLT, here it is. Any ONUs that come along, the core never explicitly said, add this ONU. The OLT adapter said, I'm adding this ONU on the ONU's behalf. You never actually go into the core API via northbound, say, add ONU, add ONU. And that's kind of the difference. There's so much state and tracking of device state that's done separate from the core, right? So the only call that's made to the core from the northbound API originally is add OLT. Everything else that's done is driven from the OLT adapter, ONU adapter for everything else. Short of the core saying.
So again, you know, if I've enabled my OLT, sent the event off to the adapter, and from an operator's point of view, I expected to see the OLT device and 2 ONUs, and I don't see the ONUs.
Right.
Where do I go from there?
How do you know when something's not there, but you think that? Yeah, and this gets into the OLT indications in the open OLT adapter. If they're there but not handled properly, event. If they're not there at all, then it's now, well, what's like the hardware itself doing event, right? There's got to be some way of stepping your way down the stack and saying, you know, I didn't fulfill my handoff obligation all the way to the fiber plant itself.
Yeah.
So, I mean,
going back up, kind of. Go ahead.
I was just saying this is where the eventing.
I think what I'm going to do, I'm going to go through all the questions that I have. The reason is because on each one of them we can talk a lot, but just to show you like some of the thinking that I had, and then also some of the other challenges that we may not be thinking of.
Go back to the previous page again, so I can refresh us. We don't remember. We don't forget what was the question. What?
That was transaction boundaries, like where in the core when we do consider transaction to start and when it does ends. That the core no longer have to do anything with it.
Okay.
The second one is the mechanism to report success and failures. Like we know all requests are async. There's no synchronous request per se. First, when we get a request, do we need to send an ACK back to the northbound interface? there is adapter needs to act back to the core. And for any response, whether successful or a failure, should we post something on Kafka? And any components, actually, like even the adapters, should they post something on Kafka if any of the action fails? And the last one I add there, it's like in order to report and to have end-to-end traceability for transactions. Currently, we don't have that. We will need to have that in order to really track a transaction end-to-end. And I'm just going to the other questions. One is transaction ordering and failure. If in the core we go and do retries, then how long do we retry? And does retry on one transaction prevent another transaction from being executed? Here I have an example. We have a logical device A that represent OLT1 that has 3 ONUs, ONU1, ONU2, and ONU3. We have one transaction that says add flow F1 to A, which decomposes to flows to OLT1 and ONU1. Then I have add flow F2 to A again. This one is flows to OLT1 and ONU2. What happens if OLT1 takes forever doing transaction 1? Does it mean that transaction 2 waits forever until transaction 1 is completed? And what would be the case if it was the ONU1 that was taking forever? So in terms of ordering, if we had to do retries, or some transaction just like being queued and just being waiting in the core? And that come back to how many retries do we want? And what should be the timeout? And do we need transaction rollback? It's something that we tried to do and didn't happen. Do we need to roll back the transaction? Meaning in the model, change the state to what it was before. Another question that I have is what should be the core behavior when an adapter is down? Like here I have another example, well, similar example. Here we're adding a flow to OLT1 and OLT2, and suddenly the ONU adapter goes down. The add flows to the ONU, we send that on Kafka. It will remain on Kafka until the adapter comes back up. However, the adapter is stateless, doesn't have any idea of that device at that time. So even if we'll get that flow request on the Kafka, it doesn't know what to do with it. Because the first thing the adapter will need to do, will need to register with the core. It will receive a reconciliation request from the core for each ONU, in this case, each ONU that it owns. And once it receives, reconcile those devices, it's only after that that it can process that flow request that was there. So is it reasonable to expect that the ONU will keep all the requests prior to going down before then do the reconciliation and then process them? Or should the core just have a heartbeat mechanism with each adapters, and if the adapters fails, and if we get a flow request and the adapter has failed, just send for example, a flow modification failure to the OpenFlow controller, even if it's a partial failure. And another example of something similar to that would be, we have the same logical device, all devices are active, and we have a request to disable one of the OLT, for example. And let's say the OLT adapter goes down. So in the core, the device states for that OLT1, before we get the disable request, was enable, operational state active, connection reachable. We have changed the state to admin to disable, operation remain active, connection remain disabled, and now there's nothing that comes back and says update those states because the OLT adapter has gone down. So what should happen? So those are some of the questions that was coming in my mind when I was thinking of transactions.
Does that not stop being reachable if the adapter goes down? Like, is the connection not reachable when the adapter goes down? Because then all you have to do is notice that
No, it's
your states are out of sync.
Yeah, sorry, I did. Go ahead. I didn't follow that.
I think the reachable reflects reachability to the hardware. It doesn't reflect reachability from the core to the adapter.
Exactly, because we don't want the core to change those operational or connection status.
Okay, so we've talked about this point a couple times. Does it not make sense to have another connection state, some kind of adapter reachability?
So adapters are reachable via Kafka today, right? And Kafka does maintain a message queue if essentially the message stays in queue until someone takes it. So if an adapter restarts, which is what we should expect, then is it really a reachability issue, I guess? I mean, we know if the adapters are down by looking at Kubernetes more than anything else.
Right? When the adapter starts up, it registers, and if that registration is on a heartbeat or a timeout or whatever, then, I mean, we know the registration state by virtue of like running the adapter's API command. It's like, oh, there's an adapter there registered, ready to go. Maybe just presenting that in addition to these someplace makes that clearer.
Yeah, and it would have to be turned into heartbeat, because I believe right now, once it's registered, it stays registered for eternity, even if the adapter actually goes away, unless that's been changed.
All right. Well, so then maybe it needs to be more.
Yeah, currently, if the adapter goes down and comes back up, it will send a register message again to the core. And if it was an existing adapter, the core will send it a reconcile message for all the devices that it owns, so that it knows what are the devices that it was managing before. That functionality, I don't think is implemented in the OpenVOLTHA adapter yet, but the mechanism is there.
I think it would be valuable to have, as part of the adapter record in the core, a last heard from, if you will, timestamp, so that when you do an adapter list, you at least have kind of, when did I last hear from this?
Mm-hmm. So we don't have this heartbeat mechanism. This is something that we need to have.
Yeah, it wouldn't necessarily even have to be a heartbeat, although it could be. But I'm just saying, every time you get a message from an adapter, you could track that as, hey, I heard from it at this timestamp, so that if you look at the adapter list and see that I haven't heard from an adapter in quite a long time, it could be the adapter is, I'm having problems, or it could be, I guess there hasn't been a message back from the adapter. I mean, in terms of monitoring the overall system, we're
yeah.
Go ahead.
It could just be that the adapter has nothing to report to the core, right? It's working, but
Yep.
it's nothing to report. So that's why I'm thinking more a heartbeat that will force it to send something back.
I mean, in terms of monitoring the overall system, there's going to have to be something that looks at KPIs, both from the adapters, from the core, and uses some level of heuristics, if you will, to determine is the system healthy.
Mm-hmm.
It's just that, like, the core kind of needs to be aware of everything beneath it. Like this state in particular we've looked at a couple times the last couple weeks, and the problem always seems to be, hey, we don't have a connection to the adapter. We don't know if the adapter is up or down. So Okay, so all I was trying to say is just, well, if we're missing that, if the core is missing that information, we need to add that information. Some kind of heartbeat mechanism, most likely. I don't think the details are too important for this discussion, but and then separate from that, yes, we're going to need to have something to monitor the state of the whole system, but I think that's separate from the core needing to know if the things underneath it are working.
I'm not sure, and the reason I say I'm not sure is, let's say the core knows the adapter is not working. Then what? What good does it do the core?
And what should we do to subsequent requests coming from those files? Should we just reject them? Should we queue them? What should we do?
In general, so it depends on it depends exactly how we want to think about requests. It looks like we have a lot of requests that are like long-running jobs, right? So the question becomes, okay, do you want to take the effort to make a job system where we can have, okay, you send the first requests, which is, I don't know, just the enable, right? And then you can kind of hold the state of that enable and see how it's going until it actually reaches like fully active, everything's up, right? And how long exactly that job goes for, or what it covers, that's a different question. But do we want to implement a job system to be able to do things like that? I'm not sure.
I mean, I've always liked the idea of job systems, and really, you could also phrase that as kind of an intent system where I'm keeping a job as an intent, and I just keep working towards that intent, and I keep status around, has that intent been reached? But again, going back to does the core need to know that its adapters are there or not? I come back to the question, if the core does know and the core says, hey, my adapter's not there, what does it do other than the core can start, I guess, sending out the log messages that say, hey, my adapter's not there? Where if a watcher knows that the adapter's not there, such as Kubernetes is a watcher, it knows the adapter goes down, it restarts the adapter, right? So I look at the system itself as a source of information, and then around that system is a policy system, is a orchestration system, is whatever you want to call it, that sits there, and based on system state changes, such as adapters going down or something else, it does a reaction. And so the person, in my opinion, that needs to know that something's gone wrong is that system that it does the reaction. And that's kind of outside our scope, right? Kubernetes does that a little bit. But I wouldn't say that's necessarily all you need.
But what happened during that time for, like in these specific scenarios, right? The adapter comes back up, we send it a reconcile request, and these transactions about enable wasn't skew. It needs to take it out and then wait for all the reconciliation to be done and then process it. Or it does the reconciliation and the core find that this was not processed, the adapters was down, and resend it after.
So I would say that when an adapter comes up, it reconciles first before it does everything else, and then gets into a known good state. And once it's in a known good state, then it starts processing messages.
Because if we do that, then we need the core to do the retry.
Why? The cores put the message to the adapter in the queue. It should stay there until someone takes it off.
Yeah, but the way it works on Kafka, you have at time T1, you have a disable request on that queue for that adapter. The adapter went away, comes back up. It sends a register message up to the core sends a reconciliation message down, but that reconciliation is after the disable device request. So the adapter will have to take out the disabled device request first before it will see the reconcile request.
Okay, so I see what you're saying.
There's-
I see what you're saying.
there's-
Okay, I guess my question is, should be anytime adapter comes up, why doesn't it attempt to reconcile? If it's a new adapter, then great. When it tries to reconcile, the core says, hey, you're a new adapter, you're good, move on. If it's a restart of an adapter, then it actually does a reconciliation. In other words, an adapter doesn't reconcile only on event. Every time it comes up, it reconciles.
Yeah, that's the logic that is there today. So
in that case, it shouldn't have to read the event.
No, but the events are always on Kafka. So it really.
So it shouldn't have to read an event, I guess. Or is the reconciliation happening over Kafka too?
Yeah, it happens over Kafka. Because all communications are over Kafka. So it will send a register up. It will say, okay, you're registered, and here are the reconciliation that you have to do. But it's all.
So then does it become multiple queues per something, or does it become one queue is used for control messages, if you will, reconciliation, that type of thing, and one queue is used for requests?
Well, there's another problem here that you haven't considered, which is, okay, what if the adapter receives the request, pulls it out of Kafka for processing, and then crashes? Then when it comes back up,
that goes back to adapter HA, right? That goes back to adapter HA.
Right, but it's the same problem. It's the same. We need. It's adapter HA, but we still need the reconcile between the adapter and the core. And the core doesn't. It doesn't get rid of the problem. Right? Even if we could pull, even if we had a system set up so that we could reconcile and then get the new messages off of Kafka, we still have the problem that we can lose messages. So it's caught up in the same problem.
Unless there's guaranteed messaging, which requires an ACK back across the bus. You're right. Yes.
So it basically comes down to when a reconcile comes in, you reconcile first, then any in-progress jobs should probably retry then. Would that be reasonable? Because I'm assuming that jobs still exist in our in-progress, or the transactions still exist in our progress. Unless they were just one-off, like fire and forget requests, in which case that's its own problem.
We should still have, the core will still have that request. The only thing is, if we, this is a simple case of a disabled device, it could be flows, it could be different things. If we wait on those requests and keep them until we get an okay from the adapter that is changing the states and everything, do we hold back all the other transactions, like everything goes in the queue until one transaction is complete? Means pretty much serializing everything, all transactions, if they are affected.
All transactions per device.
Exactly, yeah. But in this case, it will be all transactions to adapter if the adapter itself goes down.
Yeah. See, that's not acceptable. I can say transactions per device should be serialized, but not transactions per adapter.
If the adapter goes down, then all your transactions are waiting. May not be serialized, but they're all waiting for the adapter to come back up.
And again, adapter HA should work to address some of that, i.e. have a failure or a restart, right? So yeah, if an adapter is gone, all transactions managed by that adapter, regardless of device, are halted. And adapter HA that should address that issue. But assuming the adapter's there, then transactions are serialized per device, but not per transaction or per adapter. So that if I have two OLTs and I send a device down to OLT1 and it hangs, that should not prevent additional transactions to be started on OLT2. That make sense?
Yes.
Makes sense.
And in some cases, there are some dependencies. For example, if the OLT adapter goes down, then request to the ONU adapter doesn't make much sense if they would have to send all the transactions via the OLT adapter in any case. But if the adapter is down, then the ONU adapters will have to hold onto those requests until the OLT comes back up.
Well, do we want so?
Yeah, the ONU adapter relies wholly on the OLT adapter for all of its messaging, not non-core messaging, I should say. So any OMCI channel, any inter-adapter messaging, the ONU adapter must have the OLT adapter there for that to work. So when the OLT adapter goes down, you could argue that the connection status for the ONU adapter is unreachable.
Well, do we want it to have it so that parallel dependent requests aren't permitted? So you actually have to send, okay, here's the first request, make these changes. You have to wait for that job or that transaction to complete before you send something that depends on it.
No. Oh, I see. That depends on it.
Right, like you want to be able to send things that aren't dependent, right? But
that gets real complicated real quick.
Well, it's not complicated only because in the, like if you take the auth agent as an example, right? You're kind of just serializing the requests. You don't have to.
I guess where's the knowledge of A? This depends on, A depends on B. Right. Somewhere there's got to be logic to be able to analyze the requests, pending requests, and say, okay, I've got A, it's pending. Let me look at the next one. Oh, this one depends on A. I can't send it. Oh,
Right.
C. Oh, that can send that. Right. Somewhere there's got to be that logic. And that logic can be complicated because there may not be a direct dependency. There may be an indirect dependency. And do I just worry about direct dependencies or indirect dependencies? And what happens when that changes?
There's some minimal dependencies that we can figure out. For example, if an OLT adapter is down, if we have a request for a certain device, let's suppose an ONU adapter, if we can look at the adapter, the parent device of that ONU, if that parent device is supported by that OLT adapter that's down, then we can block that request. So there's some minimal that we can do, but we can't look at all the possible dependencies. For sure.
This is why locking dependency based on device, i.e. serializing requests to a device is simple, right? It gives you that one blocking factor.
So does it make sense to do so the problem with serializing is basically speed issues, because many things can depend on many other things, right? Things in the ONU can depend on the OLT, and so you have that multiple levels of dependency. So serializing becomes slow because if you have lots of ONUs under an OLT, you have to kind of serialize all those requests together. Do I understand that correctly?
I guess what I'm not sure what we're arguing, right? If we're arguing that if we had a more detailed dependency thing and could let some requests happen in parallel and others not, would we have an overall better throughput through the system? I would agree with that. I guess I say that that's complicated, and I'd be satisfied with just a simple serialization per device.
That makes sense to me.
So so the question still then comes up to, even if we're doing simple device serialization, when an adapter goes down, what happens when that adapter comes up? How does it reconcile, and how does it get back transactions, if you will, or requests that were in flight? Now, if I think in-flight requests, again, are going to somehow be, in my mind at least, they're handled by HA, right? I'm kicking that can down the road. That somehow a request is not accepted by an adapter until it is persisted, right? Or in a state where HA will recover it. The second thing in my mind is, what does reconciliation do between an adapter and the core? And is that part of that reconciliation, or should part of that reconciliation essentially be tell the adapter the intended state of each of those devices? In other words, I already enabled that device, so that device should be enabled. If it's not enabled, make sure it's enabled. So it's not resending the request so much, it's saying, here is the core model of the state of all the devices you managed. It's now your responsibility, adapter, to make A look like B, if you will.
This is the model that is in the core currently. When we do reconcile, we take the current state of the device, we send it to the adapters. Okay, so currently, like there's nothing on the adapter to do anything with it, but that's the intent.
Okay, well then that's a different issue, right? In theory, then, if a request was not complete when the adapter crashed, shouldn't it? What do I want to say? Shouldn't it then use that state reconciliation to get things back in the right order?
It also becomes so transactions that are going all the way down. Are we assuming that new transactions have to be verified by the adapter before they get into the core state? Or can I send a request for a change, have it update the core state, and then have that pushed just as a, like, think of it more as a diff than a, so kind of the idea of, like, can we merge multiple requests and apply them to the core model, and then simply push the diff to the adapters?
Oh. Yeah, I get that. There's an assumption that as part of reconciliation, the adapter essentially says, I know what my current state is, I know what my desired state is, I can enact all the things I need to do to get from one to the other. Therefore, all I'm really doing at any given time is updating the adapter with the new desired state. And the adapter should be able to reconcile to that new desired state. So it doesn't matter if there's 1 request or 10 requests. All I'm doing is say, here's your new model that you should look like. Go make it happen. I mean, at some level, all the requests on the Kafka bus are doing is a way to sync desired state between the core and the adapter.
The only difference with that model, and I'm not sure how it's done today. I don't think it's done like that today. The difference with that model, though, is it's simpler in the sense that sort of you can group a bunch of changes and send them all at once, but it's more difficult if you have issues because you don't know what transaction caused that issue.
Mm-hmm.
Right? So you could do things like, okay, take all the transactions we have currently, bundle them into one change, and try to make that change. And if it fails, fail all of those transactions, not just as a group, which is faster and sort of deals with the failure case, but it means that more places are going to have to retry, and it's a lot harder to debug wrong.
So bouncing up again, Ken, I'm not quite sure what you wanted to get out of this discussion.
I wanted that discussion to, like it's people to think it, to give it some thoughts, and
Right.
maybe it's something that we can carry on VOLTHA discuss, or maybe have a subsequent discussion on TST on this. But it's more to let people know, like, it's some of the thoughts, some of the issues that we can face when we are thinking about transactions.
Yep.
Maybe we need to have the HA discussion and get that nailed down first. Because if, let's say we're running in an HA setup in a replica set or a stateful set or something where every Kubernetes node has an adapter instance and we lose all of them, we may have bigger problems.
Yeah, you might. My Kubernetes cluster died. What do I do? Why my Volt isn't working?
You're done. Yes, it's pull from backup.
Yeah, find a new job. Yeah, okay.
So I think once we kind of solve HA, then maybe we can kind of address some of these. Now, what happens when all the instances of the adapter goes away? Kind of scenario. Anyway,
that's it. That's a good point too. Right? That's because even when we are thinking about reconciliation here, once we send the device state to the adapter, at that time, the actual device could already have been unreachable. The operational state could be in a different state that during that time have gone to, right? So we're sending a state, a desired state, actually that is not really reflected of what has happened in the network. So having HA for adapters there, I think will help to make this discussion maybe a little bit simpler.
And I'm just going to do a time check. I hate to interrupt the discussion, but we've got about 5 minutes left before we need to wrap. So we can allocate, that's all right. We can allocate some more time on a follow-up meeting. We can target a discussion for the adapter HA discussion. We can continue on VOLTHA discuss. All of those things are options on the table. So also a little bit of some admin things. Ken, I noticed, I think you've got your standard footer on this. If I could just get you to confirm that it was okay to have this presented on a public meeting. You have the confidential footer on there.
Oh, that's all right.
Yeah, okay. Just doing that for admin reasons.
The cat's sort out of the bag on that one.
and then if it would be possible to share the slides on VOLTHA discuss with the modification to the footer, that'd be appreciated as well. We're about out of time, so do we want to try and schedule a standalone meeting to continue related discussion, or try VOLTHA discuss first? Any preferences from the group?
How about we have a follow-up on the adapter HA first?
Okay.
And then we'll go with this one.
And do we have anyone who wants to start working on some material to to lead that discussion. And if you don't mind, I'm going to take presentation rights back. Do you have any volunteers to put together some talking points for the adapter HA discussion?
I'm hoping everyone's secretly busy on stabilization.
But I can do that if nobody's like wants to do it.
It's not a secret anymore.
I can put some. I can put some more questions.
Okay. So Ken, I'll work with you then to put a time slot for one of our Thursday calls, probably.
Yeah,
sure. Okay, thank you. And then I've got just a couple minutes left, and I'm not sure if we have the right folks on the call at this point. I think Girish dropped. I don't see Dinesh. So from the FCAPS discussions, I believe we're fairly certain that this redfish importer topic will be on this Thursday's call, but I just want to confirm with Dinesh. And then the multiple TCONT discussion, I wanted to confirm with Girish, but I believe he's dropped from the call today. So I'm fairly certain this first topic will move forward. And then the second one is still TBD, but we were tentatively targeting multiple TCONT discussion on this Thursday. Then we'll also defer the discussion of new JIRAs. We didn't have that many this time. We'll try and cover those on Thursday's call as well. I'll just send out a couple questions for folks if you could take a look at these offline and then update JIRA as needed. That would be appreciated. And we've got probably about 30 seconds left. Anything else that we need to cover with the group this morning? Or today, depending on your time zone?
Last question, back to Ken. Is the question addressed today, is that just a 2.0 issue, or it was also should be in 1.x, but we just didn't address that back then?
Oh yeah, it is in 1.x. We just never address it.
Okay.
Okay, anything else?
The only difference with 1.x was all the adapters were within the core itself. So that make it much simpler than now that everything is in their own Docker containers.
Okay. And one last comment. You know, I know the Docker or whatever Kubernetes is the basis of the whole implementation, but is there any way we can make it has less dependency on the Docker or the Kubernetes on the consideration? You see what I'm saying here? What if we change a different Docker management later, then will the whole framework get affected and change?
And I guess
if
you'd
you
still
decide
have
to
to
use Mesosphere instead of Kubernetes?
I don't know. I'm just very forward looking.
Yeah, or backwards.
Yeah. Thanks for the reminder, but you know, I'm just wondering whether there are dependencies.
I mean, it would be the same then if you pull out Kubernetes, then now you're responsible for your networking, you're responsible for your HA. Now you need to run your 3 or 4 or 6 Docker container instances for your adapters. Right. I mean, it's like anything you get in terms of advantages now you've already got to account for anyway. And if you're already buying into that, then you're already going to stitch together your 3 ONU adapter instances to make them work together. As long as the process that runs in the Docker container is built to run 3 at a time or 4 or 5 or 8 or whatever against a single Kafka or multiple Kafkas, and Kubernetes just make sure it all runs at the same time, you can swap out the Kubernetes and just be signing yourself for a lot of work.
The one thing there where that might be harder or not possible, and Kent, I know hopefully you're still on, how much of the Kubernetes API is the Affinity router using today? I know you've been making some changes around how some of the pairing's done. Has that been able to, is there still a dependency in the Affinity router or Affinity router D really on Kubernetes?
So there is the exact way that the routing is done has been changed. So
We're actually 5 minutes late for the SEMA meeting.
Yeah, we need to wrap up so we can head over to the other call.
Short answer is there might be some issues there.
Yes. So there are certainly some issues there.
I think there's still some dependencies there because we need to, if a call goes down, the efficient router needs to know, need to query the cluster to figure out like which call has started and all those things. So I think there is still some dependencies there.
Okay, and with that, we are a little over, so I'm going to go ahead and close today's meeting. Thanks, everyone, for the discussion. Ken, thanks for putting together the questions to lead the discussion today, and we will talk again soon. Thanks, everyone. I'll stop the recording.